The skies of 1940 were ruled by metal. Britain desperately needed an aircraft that could penetrate Hitler's fortress Europe, but every single ounce of aluminum and steel was reserved for fighter planes like the Spitfire and the Hurricane. To build a new, fast bomber meant diverting critical strategic materials, a decision that could cost the Battle of Britain. It was a critical paradox. The war demanded a faster bomber, but the nation couldn't afford the materials to build it. Standard Allied bombers were lumbering, heavily armored giants that relied on defensive guns to survive. They were slow, they required massive crews, and their losses were devastating. The Luftwaffe believed that speed and heavy armament were mutually exclusive in a bomber design. They were fixated on the weight of protection. The Allies needed the protection of sheer speed. The military needed a solution that was faster than any German fighter, yet consumed none of the critical resources required for defense. The answer came from the visionary de Havilland design team. Their solution was so radical, so unorthodox, that the RAF initially dismissed it entirely, a bomber built almost entirely of wood. This is the incredible, untold story of the de Havilland Mosquito, nicknamed the Wooden Wonder. Utilizing non-strategic, lightweight materials like plywood and balsa wood, the designers crafted a revolutionary light attack aircraft. When the Mosquito took to the skies, it immediately silenced its critics. Powered by two mighty Rolls-Royce Merlin engines, its sleek wooden fuselage allowed it to reach speeds exceeding 400 miles per hour, making it faster than almost every German fighter plane in service. It didn't need defensive guns because it could simply outrun the Luftwaffe. It performed precision strikes, photo-reconnaissance, and night raids, becoming the most versatile and valuable military aircraft of the war. We begin our deep dive into the engineering genius, how simplicity, radical material science, and sheer speed delivered a knockout blow to German air superiority. Don't miss it! Subscribe now to unlock the full story of the Wooden Wonder and the radical material that won the race against the Luftwaffe. The year is 1940. Britain stands alone against the Nazi war machine. The Royal Air Force desperately needs a medium bomber capable of fast, deep penetration into German airspace. However, the nation faces a severe shortage of strategic materials, primarily aluminium and high-grade steel. Every single sheet of metal is prioritized for fighter aircraft, the Hurricanes and Spitfires, that are fighting the Battle of Britain. Building a new, large metal bomber would be a drain on the nation's lifeblood, a politically and economically impossible choice. The RAF needed speed and range, but the traditional materials for achieving these goals were simply unavailable. The challenge was taken up by one of Britain's most brilliant but unconventional aircraft designers, Geoffrey de Havilland. While the Air Ministry insisted on heavily armored, defensive bombers carrying large crews, de Havilland proposed a radical departure. His philosophy was based on a simple premise: speed is the best defense. He envisioned a light, twin-engine aircraft so fast and so streamlined that it could fly deep into enemy territory and return before any German fighter could catch it, let alone shoot it down. He deliberately ignored the current military doctrine. The de Havilland team proposed a two-man aircraft with no defensive armament whatsoever. This was unheard of. By eliminating heavy gun turrets, machine guns, and the weight of the extra crew members needed to man them, the aircraft could shed thousands of pounds. This reduction in drag and weight was the key to achieving the critical speed advantage. Initially, the military planners were skeptical, viewing the design as criminally negligent. How could a bomber survive without guns? De Havilland's response was simple: it wouldn't need them. To solve the aluminum crisis, de Havilland made the boldest choice. He would build the aircraft primarily from wood. Specifically, the fuselage was constructed from a revolutionary sandwich of balsa wood laminated between layers of Canadian birch plywood. This choice was brilliant. Wood was a non-strategic, readily available material. It was light, easy to mold into aerodynamic shapes, and possessed surprisingly good strength-to-weight properties. What started as a material compromise quickly turned into the Mosquito's greatest secret weapon. De Havilland designated the prototype the DH.98. When presented to the Air Ministry, the design was nearly shelved. Military leaders dismissed the wooden aircraft as a folly and a flimsy toy, doubting its ability to withstand combat stress. The project was almost cancelled several times, designated a low priority, and survived only because de Havilland relentlessly advocated for it and managed to secure a small amount of funding based on its potential as an unarmed photo-reconnaissance aircraft. The aircraft that would become legendary was born from near rejection. Despite de Havilland's unwavering conviction, the Air Ministry remained deeply skeptical of an unarmed wooden bomber. To keep the project alive, de Havilland cleverly pitched the DH.98 not as a bomber, but as a fast, unarmed photo-reconnaissance aircraft. This reconnaissance ruse was a tactical move to circumvent the military's rigid doctrine. The Air Ministry, desperate for any advantage in intelligence gathering, grudgingly approved a small contract for prototypes under this guise, giving the wooden wonder a critical lifeline, even if its true potential remained unrecognized by most. With minimal official backing, the development of the DH.98 proceeded with an almost clandestine urgency at de Havilland's Hatfield facility. The project was kept under tight wraps, largely hidden from public scrutiny and even much of the Air Ministry. This secrecy allowed the design team to push boundaries without constant bureaucratic interference. Working away from the spotlight, they meticulously crafted the wooden fuselage, pushing the limits of aerodynamic efficiency and refining the unique bonding techniques that would give the Mosquito its unparalleled strength-to-weight ratio. A key to the Mosquito's astonishing performance lay in its engines. De Havilland chose two of the most powerful and reliable piston engines of the era, the Rolls-Royce Merlin. These liquid-cooled V12 engines, already proven in the Spitfire and Hurricane, were incredibly powerful for their weight. By pairing a lightweight, aerodynamically clean airframe with two high-performance Merlin engines, de Havilland created a power-to-weight ratio that was simply unmatched by any comparable bomber. This combination promised a speed advantage that no German fighter would be able to counter. On November 25, 1940, the DH.98 prototype, now unofficially known as the Mosquito, took to the skies for its maiden flight. The results were nothing short of astonishing. The aircraft was incredibly agile, responsive, and, most critically, blazingly fast. Test pilots reported speeds far exceeding initial estimates, leaving even the most optimistic designers stunned. Its performance immediately overshadowed every other bomber in development and even rivaled many contemporary fighter planes. The wooden toy was already proving itself to be a true thoroughbred. The raw performance data from the first flight tests was undeniable. The Mosquito was faster than the latest Spitfire, faster than the latest Messerschmitt Bf 109, and could easily outrun virtually any bomber in service. This undeniable speed forced the Air Ministry to re-evaluate its stance. The initial skepticism evaporated, replaced by a sudden, urgent recognition of the Mosquito's strategic potential. The folly was now seen as a miracle, and orders for production quickly began to mount, paving the way for its legendary wartime service. The core of the Mosquito's genius lay in its structural shell. The fuselage was built using a revolutionary sandwich technique. Balsa wood, a surprisingly durable, lightweight core, was laminated between thin sheets of Canadian birch plywood. The balsa provided bulk, absorbing strain and maintaining shape, while the hard birch plywood layers provided immense tensile strength. This created a shell that was lighter than aluminum, incredibly smooth for aerodynamics, and surprisingly robust against stresses, all achieved with non-strategic materials. De Havilland's material choice transformed the production process. Since the Mosquito was wood, it could be built by companies that had never touched aircraft before. Cabinet makers, piano factories, and furniture manufacturers, businesses equipped with vast woodworking tools and skilled joiners, were immediately mobilized. This unique, furniture-style production meant that the Mosquito could be mass-produced in scattered, hidden locations across Britain and overseas, completely bypassing the heavily burdened traditional aircraft industry. The key component holding the revolutionary structure together was not nails or bolts, but a sophisticated adhesive, Tego Film. This thermosetting, plastic resin adhesive was applied in thin sheets and cured under heat and pressure. It created a bond that was stronger than the wood itself, impervious to water, and resistant to extreme temperature changes. Tego Film was the unsung hero of the Mosquito. Without this chemical triumph, the wooden components would have separated under the intense strain of high-speed flight and combat. To maintain the incredible production pace, the Mosquito was designed for modular construction. Fuselage halves were built separately, like two halves of an immense wooden boat, in different locations, often by different companies. These modules were then shipped to a central assembly point where they were joined together, sanded smooth, covered in doped fabric for weatherproofing, and fitted with the engines and equipment. This decentralized, interchangeable design was crucial for maintaining output, especially under the threat of German bombing raids. In combat, the Mosquito's wooden construction proved its pragmatic value. Unlike metal planes which required specialized tools and welding to fix major bullet holes and tears, the Mosquito could often be repaired using simple woodworking technique. Skilled repair crews in forward bases could quickly patch combat damage with new pieces of plywood and glue, allowing a damaged Mosquito to return to the fight far faster than its metal counterparts. Simplicity and accessibility were massive advantages in the intense rhythm of wartime operations. The Mosquito bomber variant, designated the B.4, quickly earned a fearsome reputation. Due to its sheer speed, it became one of the few aircraft to routinely fly deep into German territory without fighter escort. While it carried a lighter bomb load than the massive Lancaster, the Mosquito could deliver its payload with unprecedented speed and precision, often performing daring, low-altitude daylight raids where a slow, heavy bomber would have been instantly annihilated. Its doctrine was simple: arrive fast, drop bombs, and disappear. The Mosquito proved invaluable in its original, officially sanctioned role, photo-reconnaissance (PR). Flying at altitudes up to 30,000 feet and maintaining speeds that left the latest German interceptors scrambling, the unarmed PR variants, like the PR.9 and PR.16, flew repeated, critical missions over the most heavily defended enemy targets, including the V weapon sites and Berlin. They captured the high-quality intelligence necessary for planning D-Day and strategic bombing, earning the Mosquito the nickname, the Ghost of Berlin. When fitted with early airborne interception radar, the Mosquito transformed into a devastatingly effective night fighter, NF. Its speed and maneuverability made it a superior platform for hunting German bombers over Britain and later, chasing Luftwaffe night fighters over Europe. The NF variants were heavily armed with nose-mounted cannons and machine guns. This role highlighted the versatility of the wooden design, proving that the Mosquito could not only run from enemy fighters but also successfully run after them in the darkness. The most widely produced variant was the fighter bomber, the FB.VI. This highly versatile aircraft was often deployed in anti-shipping roles, armed with cannons, machine guns, and later, 8 high-explosive rockets. The FB.VI became the terror of coastal convoys and U-boat refueling ships, using its speed to dash in at mast height, deliver a punishing strike, and escape before defenses could react. It was a true multi-role machine, proving the wooden wonder was tough enough for the unforgiving maritime environment. A definitive example of the Mosquito's precision and daring came in March 1944 with Operation Jericho, a low-level raid on the Gestapo prison in Amiens, France. Mosquitoes flew at rooftop level to blow open the prison walls, allowing resistance fighters and political prisoners to escape. This mission demanded incredible piloting skill, pinpoint accuracy, and the confidence that the aircraft's speed would protect it from ground fire. The successful, high-stakes raid became legendary, cementing the Mosquito's reputation for precision strike. The Mosquito's legendary speed wasn't just a number, it was its primary defense. Early in the war, it was often faster than the latest German interceptors, including the formidable Messerschmitt Bf 109 and Focke-Wulf FW 190. When a Mosquito spotted an enemy fighter, its pilots didn't engage. They simply opened the throttles and outran them. This constant ability to run for home demoralized German fighter pilots, who expended precious fuel and ammunition fruitlessly chasing a wooden ghost that simply vanished into the distance. An unexpected advantage of the Mosquito's wooden construction was its inherently low radar signature. Compared to metal aircraft, the Mosquito reflected far less radar energy, making it much harder for early German ground-based radar to detect and track. While not a deliberate stealth design, this property provided an additional layer of protection, particularly during night raids and reconnaissance missions, allowing the Mosquito to slip through enemy air defenses more often than metal bombers. During the devastating Battle of Berlin bombing campaign, the Mosquito played a crucial, often overlooked, role. While heavy bombers attacked in waves, Mosquitoes were used for two primary functions: pathfinding, marking targets with flares for the main force, and harassing raids. On nights when heavy bombers were grounded by weather, Mosquitoes would still fly over Berlin, keeping the city's air defenses constantly active and disrupting civilian morale, preventing them from recovering. The Mosquito's speed and stealth made it a formidable psychological weapon. Its ability to arrive over German cities with little to no radar warning, drop its bombs, and vanish before a significant defense could be mounted, created a profound sense of insecurity. The constant, unannounced night raids by the Mosquitoes, often striking high-value targets with precision, kept German civilians and military personnel on edge, disrupting sleep and maintaining constant pressure. Towards the end of the war, de Havilland experimented with even more powerful engine variant. Some Mosquitoes were fitted with the immense Rolls-Royce Griffon engines, a larger, more powerful successor to the Merlin. These Thunderbolt Mosquitoes pushed the aircraft's speed even further, approaching 430 miles per hour. While never mass-produced in large numbers, these experiments demonstrated the enduring potential of the Mosquito airframe and its capacity for even greater performance. In September 1942, a daring daylight raid by Mosquitoes targeted the Gestapo headquarters in Oslo, Norway. Flying at incredibly low altitudes, the aircraft achieved complete surprise, hitting the building with devastating accuracy. This mission, while having limited strategic impact, was a profound psychological blow to the German occupation and a powerful demonstration of the Mosquito's ability to penetrate heavily defended areas with precision, operating far from its home bases. It served as a clear warning that no target was truly safe. One of the most audacious and tragically remembered Mosquito raids was Operation Carthage in March 1945, targeting the Gestapo headquarters in Copenhagen. Flying at treetop level, the Mosquitoes once again demonstrated pinpoint accuracy, destroying the building and freeing many prisoners. However, in a tragic incident, one Mosquito crashed into a nearby school, leading to civilian casualties. Despite the unfortunate outcome, the raid underscored the Mosquito's capability for incredibly precise, high-risk, low-level strikes against fortified targets. The Mosquito didn't just outrun the Luftwaffe, it often attacked it directly, even in its own lairs. Fighter-bomber variants of the Mosquito frequently conducted daring low-level, intruder missions, sneaking onto German airfields at night or dawn to destroy enemy fighters on the ground as they were preparing for or returning from missions. These Mosquitoes, targeting Hornets, were incredibly effective in disrupting German air operations and reducing the number of fighters available to intercept Allied bombers. On June 6, 1944 D-Day, the Mosquito played multiple crucial roles. Photo-reconnaissance variants provided vital intelligence of German defenses and troop movement. Fighter-bomber Mosquitoes flew ground support missions, attacking German strongpoints and troop concentrations threatening the landing beaches. Furthermore, Mosquitos were instrumental in creating diversions, flying circuits to jam German radar and deceive enemy defenses about the true location of the invasion fleet, protecting the massive Allied armada. Flying the Mosquito, particularly its precision low-level missions, demanded exceptional skill, courage, and navigation from its two-man crews. Pilots like Wing Commander Guy Gibson, initially considered for Mosquitos before the dambusters, and countless others pushed the aircraft to its limit. These elite airmen flew without defensive armament, relying solely on their aircraft's performance and their own abilities to survive and accomplish missions that were often deemed impossible by conventional standard. The sheer effectiveness of the Mosquito deeply frustrated the Luftwaffe. Recognizing its unparalleled speed and versatility, German engineers attempted to develop their own equivalent, even going so far as to copy the wooden construction. The most notable attempt was the Focke-Wulf Ta-154 Mosquito, deliberately given the same nickname. This was a telling admission of the superiority of de Havilland's design. Germany, a nation famed for its metal aircraft, was now trying to build a wooden one to counter a wooden one. For German fighter pilots, the Mosquito became a symbol of frustration. They spent countless hours chasing these elusive, fast-moving targets, often without success. This constant evasion and the inability to effectively counter the Mosquito's speed took a severe psychological toll on Luftwaffe morale. The wooden wonder wasn't just a physical threat, it was a demoralizing ghost that constantly reminded them of their technological disadvantage in high-speed, high-altitude engagements. German efforts to counter the Mosquito faced significant technical hurdles. Their early ground-based radar systems struggled with the Mosquito's low radar signature. Furthermore, developing interceptors that could match the Mosquito's speed and altitude capabilities proved incredibly difficult. While late-war German jets like the Me-262 eventually surpassed its speed, the Mosquito operated effectively for years before such advanced technology was widely available, constantly pushing the limits of German air defenses. After World War II, many Mosquitoes continued to serve with various air forces around the globe, including those of the UK, Canada, Australia, and New Zealand. Its versatility meant it was adapted for roles such as target towing, photo surveying, and even as a fast transport. While overshadowed by the jet age, the Mosquito's robust design and excellent performance ensured a respectable second life, demonstrating the enduring quality of its wooden wonder engineering for years after the conflict. The German attempt to create their own Mosquito, the Focke-Wulf Ta-154, ultimately failed. While it shared the wooden construction, a critical shortage of suitable glues, unlike the British Tego Film, and an over-reliance on experimental bonding methods led to catastrophic structural failures in flight. Furthermore, Allied bombing raids on glue factories further crippled its production. The Ta-154's inability to match the original's quality highlighted the depth of de Havilland's material science and manufacturing expertise. Today, the surviving Mosquitos are cherished museum pieces, physical testaments to an extraordinary era of ingenuity. Due to their wooden construction, they require specialized conservation techniques to prevent deterioration and maintain their delicate structure. Each remaining Mosquito is a precious artifact, allowing modern audiences to marvel at the elegant lines and radical materials that defined this legendary aircraft. These static displays are crucial in educating future generations about the wooden wonder. The passion for the Mosquito extends beyond static displays. A dedicated community of enthusiasts and experts worldwide undertakes incredibly complex and expensive restoration projects, aiming to return these wooden marvels to flying condition. These efforts are monumental, involving meticulous woodworking, engine overhauls, and sourcing original parts. Witnessing a restored Mosquito take to the sky is a powerful, visceral experience, connecting us directly to the speed and sound of its wartime glory. The Mosquito's unique story and daring exploits have cemented its place in popular culture. It has been featured in numerous books, documentaries, and films, most notably the 1969 British war film Mosquito Squadron, which highlighted its precision bombing capabilities. These portrayals, while sometimes dramatized, helped to popularize the aircraft's legend, ensuring that the story of the wooden wonder continues to captivate audiences and inspire awe for its remarkable achievements. The de Havilland Mosquito remains an enduring symbol of British wartime ingenuity and the triumph of unconventional thinking. At a time when resources were scarce and the odds seemed insurmountable, a small team dared to challenge conventional wisdom, proving that innovation isn't always about brute force or exotic materials, but about clever design and pragmatic application. It stands as a testament to British engineering prowess under immense pressure. Andrew Higgins's greatest invention was not just a boat, it was the key to amphibious victory. By solving the problem of the final few yards of water, he fundamentally transformed the nature of naval warfare. The LCVP proved that the most complex military problems can sometimes be solved by the most basic, pragmatic engineering. His legacy, cemented by Eisenhower's quote, remains a powerful reminder. The man who built the simple wooden boats was the man who provided the tools to win the war. The de Havilland Mosquito was more than just an aircraft, it was a revolution. Born from necessity, built from wood and driven by raw speed, it defied every conventional expectation of a bomber. It outran its enemies, performed a dizzying array of roles, and demonstrated that elegance and ingenuity could be a more potent defense than armor. The wooden wonder truly earned its place as one of the most remarkable and versatile aircraft of World War II, a testament to the power of thinking outside the metal box.